mobile applications that were being deployed to consumer-owned devices. So the government's really good at testing software that gets deployed to government servers, but they're not really good, or they had not at that point had anything that would be deployed to a consumer-owned device. A little bit about me. Certified information privacy professional with a focus on government. Former Microsoft MVP for device application development. I've been doing software development and information assurance work in the defense market here for about the last 13 years. And there's some contact information and a very outdated blog. So as I mentioned, this framework provides the procedures for security and privacy testing for mobile applications. It is not going to be an end-all and be-all security testing framework for exploitation. It's purely focused on security of the data on the devices and the privacy of the data on the devices. And we have a three-part test process, which includes technical testing, source code review, and developer interviews. The first part with the technical testing, you actually want to have hands-on for the device. In this case, we use a mix of Android and iOS devices. I suppose Windows Phone has some small market share. Although in this case, the government was not deploying to Windows Phone, so we didn't have any tests that were written for this. But the actual test procedures themselves are agnostic enough that you can apply them to just about any operating system or platform. Recommend at least one jailbroken or rooted device. Some way to connect the device to a laptop so you can inspect the device file system, some kind of protocol analysis software, Wireshark, whatever your favorite tool for that is. And what we're trying to find out here is, does the application do what it's supposed to do? Developers are great. Any developers in here? All right. So no offense, but I was a developer once too. Developers are great at, theorizing about software. Delivery of it, sometimes a different story. Doesn't always do what it's supposed to do when it gets to the real world. Second part of it we do is source code review. And again, we're not looking at the entire spectrum of code. We're looking at the stuff that pertains to the security of data on the device and the privacy of that data. And we're specifically not looking at end user functionality. If you click a button and it doesn't do what it's supposed to do, we're not really concerned about that. External libraries may or not be reviewed and tested. Depends on the level and criticality of information being processed by the application. And some people used to ask, why do you want to test their external libraries? C#. Interviewing the developers. So this part, in order to facilitate a faster turnaround, we would have a series of questions that were presented to the developers in advance. They would fill those questionnaires out with the relevant information that we were looking for, and then we would be able to conduct our interview, or as they felt, it was an interrogation. Every time IA sits down with the developer team, they feel like they're being interrogated. And that is kind of a high-level overview of what that looks like. If anybody's actually interested in this, I have the printouts. You guys can contact me and I can send it to you rather than trying to make sense of that. So at this point, we'll take a look at the actual tests themselves. The first test, we want to make sure that the device or the application shouldn't run if the device is jailbroken or rooted. And again, this is looking specifically at applications that are being deployed to, or that are going to be using privacy or sensitive information. And the basic premise with that, the act of jailbreaking or rooting the device, you're compromising that system already. So you can't reasonably guarantee that something else isn't going to compromise it as well. So basically, to make sure that you're not running on a rooted device, there's source code. You look at the source code, and you can determine. You can make a function call to find out if it is broken, and that's pretty much the only test you have for that. Is looking at the source code. The second test we have insecure data storage. If you're going to persist data locally, you want to store as little information as your application actually needs locally, either in temporary cache or persistent to the file system. It should be protected with FIPS certified encryption. And to verify that this is happening, you want to interview the developer team, and then also you can inspect the device itself, looking at the file system and looking in places where information may be stored. So the things you might be looking for here, usernames, authentication tokens, passwords, persistent location data that the user's not made aware of. So for example, it's one thing to store location information if the app says, hey, we're going to store this location information. But if the app is not saying anything about that and it's doing it, that's a privacy violation. One thing interesting with this, another question I've gotten is, well, do people actually put that in source code? So there was an Android game that a group of us were recently playing, and we kind of got a little obsessed with this particular game. A couple of us took the APK for that game and reverse engineered it, and I found the Facebook authentication information for that developer is embedded in their source code. So potentially I could be them on Facebook, and I don't know. Is it the end of the world? No, but should it be there? Probably not. The third test that we're looking at are weak server-side security controls. And again, the nature of this particular testing framework is focusing more on the device itself, but the device is not, it doesn't exist in a vacuum. So typically it's going to be doing some kind of server-side interaction, either sending or receiving data. And it doesn't do you a whole lot of good if the device is strong and the data is well protected on the device, but you've got crappy security on the server side that somebody can go get that same data from. The fourth test, insufficient transport layer protection. So again, the data that is going to be on the device, if it's being sent anywhere to a remote location, you want to make sure that data is protected in transit. So if it's web requests and it's sensitive data, of course you want to make sure they're using SSL. Also making sure that if they have a secure session established and that session is broken, or some kind of other validation check fails, that the data is properly being handled or sanitized at that point and not continuing on. Again, you want to make sure that the data is protected, not only at rest, but in transit as well. Client-side injection. So that particular game that I was talking about, they actually did a really good job at client-side injection protections, making sure that any data that was input to the application on the device was properly restricted or sanitized. That was one of the first things I think all of us tried with that particular game was, well, can I just do a simple overflow or something and make it break? So making sure that you're looking at client-side injection protections. Again, you're going to analyze the source code, have your hands on the device, try it, for example, if you've got a data field there that says, please enter a social security number, it shouldn't allow you to put in like the letter A, simple things like that.
Are you using any specific buzzing tools?
I'm sorry?
Any specific buzzing tools? Like just normal?
No, nothing specific. And in fact, most of the time with a lot of that, once you have hands on the device, it's a lot of manual testing. Because at least in the apps that I've looked at so far, you can fairly quickly determine with a manual test whether you want to pursue something like a fuzzing tool. Like I said, that particular game, they did real well at their client-side protections. Another thing you want to check for is poor authorization or authentication. Make sure the device, or rather the app, doesn't rely on something like the device ID, subscriber ID, or phone number as the only means of authentication. If you're dealing with sensitive or privacy-related information, you probably want to have some kind of multi-factor authentication there so that before giving the user of that app on that device access to whatever data that is. Mostly because a lot of those things can be spoofed. Poor or improper session handling. Make sure that, in addition to not using those as session identifier or as, authentication, make sure they're not used as session identifiers either. Ensure the app has proper session timeout settings. Tokens are stored on the device, make sure that's encrypted. Test 8, you're looking at security decisions through untrusted inputs. If I'm going to change sensitive information on there, make sure the user's prompted before that data is allowed to be changed and saved, and make sure that they're authenticated at that point. I think the first time we actually put that to the test on the first government app that I was doing this for, we were able to update social security numbers in that without being challenged. And so it failed on that first round. That wasn't the only thing it failed on, but. Next test we're looking at is side channel leakage. Inspect web caches, log files, temp directories on the device for any kind of sensitive data that might leak out as a result of anything happening on the device. Coworker and I yesterday were having a discussion related to sensitive information that could potentially be stored in memory and how you might get access to that. And of course, one of the things we're thinking about, well, if you have the sensitive data in memory that was protected so that programmatically you couldn't access it, what about causing a panic on the machine so it dumps memory to a system file, like a blue screen of death on a Windows box. It's going to dump all the memory data out, and then once you recover, just start parsing through that memory dump and looking for the previously protected information. You want to make sure your application is not doing something like that with any sensitive data. Looking at broken cryptography. Always used to love hearing, you don't hear it as much nowadays, but used to hear it a lot back in, so many old timers are in here. I mean, I'm 42, so I'm pretty old. But I remember early on in my IT career, you'd hear every now and again about somebody who created their new unbreakable encryption algorithms. And it's like, what do you mean you created your own algorithm? Oh yeah, it's unbreakable. No. Let's use trusted, industry tested encryption algorithms for protecting that sensitive data. Don't roll your own. I guarantee nobody in this room, probably nobody in the city of Charleston or even the state of South Carolina, is qualified to roll their own encryption. So make sure that you're protecting it properly, using whatever encryption libraries they happen to have for your application environment. Test 11 is looking at sensitive information disclosure. Again, looking at this time, rather than looking at the files themselves, that might be on the device, looking at the source code to determine if there's any private API keys stored within the application, workflow logic, or hard-coded passwords. Believe it or not, you still come across things like private API keys or hard-coded passwords in applications out there. Did anybody else just pull down APKs and start tearing them apart just because you're... Okay, maybe I'm the only one. What's that? Oh, you do? So Adrene does too. No, it's... so yeah, you'll find some stuff like that hard-coded, and again, it's typically not a good idea. But again, it also depends on what type of information you're protecting. This is a big one from a privacy and legislation perspective, more so than anything else, and it's something that typically a lot of developers don't necessarily care about, but guarantee the business people will care about. Making sure that you have privacy warning, consent banners, and notifications in accordance with federal, state, and applicable laws. So the interesting thing here is you've got to have the proper privacy warnings in place at the point of download in the app stores. And make sure that the proper warnings are in place when the user is using the application. And the thing that bites a lot of developers in the United States is that California has some of the more aggressive privacy laws as far as the United States goes. If you compare us to Europe, we're way, way behind. But if you're looking at stateside, California kind of leads that charge with their privacy regulations. And in the globally connected nature of our economy nowadays, you can be a developer here in Charleston, South Carolina. You put an app up on, Google Play or whatever the Apple Store is, and if it's collecting privacy information and the user's not properly warned, California can come after you because somebody in California downloads that app, and the state of California aggressively protects their citizens, apparently. When they first introduced this law, this OPPA, and I can't even remember what exactly the OPPA stands for, but when they introduced that law, they kind of gave everybody a warning and said, hey, developers, we've got this law. This is how we're protecting the citizens of California, and this is what you need to do to be in compliance with it. And oh, by the way, these are the penalties for non-compliance, and we're giving you guys all warning right now. They gave about a year's warning, and then they started, pursuing that in court. And the biggest one they went out after was an airline that was collecting information. They did not have the proper privacy warnings in place, and they got hit with a several $million fine from the state of California. And they were able to successfully pursue that. So the airline was pretty sad about losing all that money, especially over something so simple.
What was it like?
What's that?
What were they like?
I'm guessing, name and address information, maybe payment information, because they were an airline. Maybe the typical information they might collect for, if you're going to purchase a ticket or something. And yeah, so they went after them, and they've slowly gone after other vendors out there that have applications to, so now it's almost, I think you can't even upload anything anymore, at least to Google Play, without having that already in place. I think the last time I checked anyway, you couldn't even upload it unless you specified in the upload, here's my privacy policy, here's where they can click to get a link to it and acknowledge that you had that stuff in your app. So again, that's a big one from a legal perspective. That's not necessarily a technical perspective. And then also we have a look at the specific device permissions. And here it's more of a kind of a good neighbor thing. Document the list of specific permissions that your app requires and the reason that you're requesting that permission. Again, this was written in mind of government producing apps. So, anytime, it's kind of the weird thing with, us consumers and giving up information. If, big company XYZ says, hey, here's this really cool app, we need all these permissions, from your device in order for you to use this app, most users are like, oh yeah, sign me up. But if the government were to ask for those same permissions, most people say, the government wants that information? I don't want to give it to them. So again, document the reason that you need those permissions. If you're asking for information, location information, explain why you're asking for that. So that is the test overview in a nutshell. Looking at some of those things from the test, you may have noticed some overlap if you're familiar at all with OSWA and a lot of their recommendations for the top security problems in application development. A lot of what went into developing this framework came from things like OSWA, industry best practices, and also security guides for various devices and other applications. Do you have any questions? Okay, gentleman in the back.
Are there any emulators that enable you to test an application, basically? What hooks into it?
So speaking specific, I can only speak for Android because full disclosure, I absolutely hate Apple and all of their products. Oddly enough, I got my start on an Apple IIe back in the dark ages of computing, right after Corsi invented Dirt. And but I don't like Apple, so I don't use them. But on Android, for example, you have an emulator that comes with the Android Developers Kit, so you can always use that. There are also third-party commercial emulators. BlueStacks is one popular emulator that's out there. That you know, it's basically just that. It's an emulator that gives you an Android virtual environment. There's another one that's called Andy, and it's basically a VM that is an Android VM. So you could, you know, put your apps on those and run them through tests with that. Does that answer the question?
Yes.
Okay. I had a gentleman in the front that had a question too.
That was the same question.
Oh, all right. So you had one in the back?
Sir, spent a lot of time reverse engineering stuff. Of all the things that you see in your experience, what is the one thing you see the most of that is the most concerning to you?
Probably the most is, you know, API tokens, or probably like API tokens, you know, because you think about it, depending on the API that's being accessed, some of those companies pay good money for access to that type of information, and then they're going to put that token hard-coded somewhere in the app, which if I wasn't a gainfully employed person with a clearance and wanting to keep that job and stay out of jail, I could say, oh, well, I'm going to take that API key and abuse it for my own purposes. So,
What's the proper way to secure that? There's a callback to your servers.
I mean, you may make some kind of an authenticated call back to a server. I mean, that might be one way. Or if you're going to store it, you know, if you really have to store it on the device, at least encrypt it or hash it or something. Don't make it so that I can just, you know, dump the APK out to some Java files and open them up and there it is in plain text. You know, at least make me work for it. Is there any other question?
Is there any difference in applying your framework when you're dealing with enterprise-only deployed apps other than Google or the App Store?
I didn't get the first part of that.
So, our frequency, a lot of our apps are only deployed through the enterprise. We don't go through the Google or the Apple process.
Okay.
And they're only developed for the
So, potentially, I mean, you could take this same framework and apply it to something that was deployed privately within your enterprise. Yeah, I mean, there's nothing, again, it's agnostic enough, platform agnostic enough that it doesn't require a particular vendor for anything. So yeah, I mean, you can take that framework and put your own internal MUSC apps through that, and yeah.
So how do the users install this?
We have our own secure website that we go to see what apps are available and install based on predictions and
Yeah, question?
So Lou, my area, this is great by the way, but I see this really as pertinent to the developer or source end of the stream, if you will.
Right.
And my great interest is on the end user end of that. What can we do? Is there any kind of testing that someone with at least a little bit of knowledge could do? And maybe this is another speech.
So no,
Maybe
that's
come back next month and speak on that. But
So that's a
Love to
good
know more
question.
about what we can do to protect the end user.
That's a good question. Are you talking about as an end user? Could you do
Yes.
something similar to this?
Yes.
My initial
I wanted to
answer.
do it on behalf of everyone here. You know?
Well, so my initial answer from an end user perspective is just be aware of what you're installing on your device. You know, I remember one of the first times. So I have a 14-year-old, 15-year-old daughter. She'll kill me if I keep forgetting her age. But I remember a few years back, she does have an iPhone, and she wanted some kind of emoji program on her phone. She's like, yeah, all the kids use it, and it's great. And I'm like, what do you need it for? Oh, well, you know, this, that, and I was like, yeah, but, so the first thing that stood out was, you know, it was come from some company in China. Now, when I used to write mobile software in the dark ages, the biggest source of piracy for my mobile apps was from China. So much, in fact, that every app that I wrote after my early days, there was always a function check when the app first loaded. It checked on the localization setting for the device, and if it was not English US or English Great Britain, it threw a random error and said, you know, please contact the vendor for support. So I saw that this app was from China, and I was like, I just didn't sit right with me. So I started analyzing that app and her device, and I found out that that emoji tool or whatever was taking every single text message sent or received on that device and storing it in a local SQLite database. And I said, why on earth do they need to do that? So they weren't making any mention in any of their documentation anywhere that they were doing it. And as far as I could tell, they weren't doing anything with it, but why on earth would you do something like that?
Well, like 5 years ago, I downloaded a tip calculator. It needed fairly root level and administrative access to the Android phone, and I'm like, this is like outrageous. But so you know, as long as I can trust that documentation, yes, I can do something with it. But I don't even trust that. I mean, the apps come from every corner of the earth.
So again, from an end user only perspective, and especially for you know, this present company excluded, most end users out there are not technical at all.
Right.
There's a higher level of technical awareness here. I would just say look at, when you're downloading these apps, look at the permissions that the app requires. So if you're downloading a tip calculator and it says it needs your location information and needs access to your camera and your microphone, and needs to be able to send and receive text messages on your behalf and make phone calls, I'd be like, you know what, tip calculator, all I need to do is put in some numbers and you spit out, you know, some numbers back to me. You don't need all those permissions. If I download a tip calculator, Google Play should tell me, you know, tip calculator requires no additional permissions.
But is that the developer that puts that there, or is Google, or in case of
So when the developer
Apple
uploads, again, speaking from an Android pipeline, when a developer uploads or creates an application for an Android device, there's a manifest file that specifies the permissions that the application is going to get. And so when you download it from Google Play, for example, it'll tell you this app needs permission to X, Y, and Z.
So I guess what I'm asking is, so I can put some level of confidence that what it tells me there is accurate.
Yeah.
I'm worried someone's really spoofing me on that.
Is there somebody to verify the permissions that that particular app needs based on what the developer gives them, or is it just, oh, I trust the developer?
A lot of it's on, do you trust that developer? So, you know, the big uproar several months ago when Facebook redid their Messenger app and everybody was up in arms like, oh, it needs access to my microphone and my camera and all that. I don't want to give it, so I'm not using Facebook Messenger anymore. Well, if you look at their word on why they need it, it's so you can, you know, send a voice message to another Messenger user, or you can, you know, I can take a picture of Corsi looking at his phone and send it to Scooter, you know, right through Messenger, and that's why they need those permissions. At least that's what they're telling you. And with a company like Facebook, you may or may not tend to believe that, okay, that's what they're using it for. They are not the NSA in disguise trying to get all of my, you know, information.
Sure they are. They want your data as much as NSA does.
They do. You have a question?
Yes, so I know last year the App Store for Android When you pushed automatic updates, you would change permissions without notifying the end user?
They've changed that since then.
Okay.
So yeah, if at least now in Google Play again, if you downloaded an app, say last year, or in times past, the app might say it doesn't need any permissions, and then an unscrupulous developer could come later and create an update for that app that required additional permissions, and the update process didn't let you know that it needed new permissions. Google has since fixed that, at least in the Android pipeline. Okay, first you and then you.
So one of your first test techniques was checking for jailbreak. A good jailbreak technique should be fairly undetectable. What kind of measures have you seen in the past to actually detect that?
I haven't seen any measures myself to try to evade that check. In fact, the code that I was using to perform those checks may be outdated at this point. This was written originally 2 years ago. So unfortunately, I can't answer that.
Yeah, so Maniac being the first thing I would think of is to test to see if I can do what would be an illicit option or an activity. But if the jailbreak failed, we could be basically crashing around the control because this kind of.
So I think that'd have to be a targeted bypass. Like if you were trying to, because like you said, every app could try to detect root in a different way, either trying to write to a specific directory or access a certain resource. So you'd have to know what that app was trying to look for. Otherwise, you could try to block and head a lot of that. Like
the original code that we were using to test for that came out of both the iOS Developers Guide from Apple and the Android Developers Guide from Google. They had a code snippet that said, here's a function call you can make to determine if you're on a rooted device. And so we just said, okay, that comes straight from the vendors themselves. We'll just use that.
So it's a little bit of prey as well.
Yeah.
Out of curiosity, on the apps that you looked at, do they use an encryption channel between the app and the server?
So yeah, the few of them that I have looked at, they are using, for example, an HTTPS connection between the client and the server.
Yeah, it's just,
Depends on whether they can run.
Any other questions?
this might have been an easy one. I think one of your early ones were encryption, making sure you encrypt what you're having. Where do you test to see what key or what authenticator, what thing they're using to encryption?
So if they're storing data and it's encrypted, what we're mostly looking for is, are they using an industry accepted encryption library, for example?
Right.
Are they using AES 256 and they're saying they're using it? Then also, are they calling or are they importing that from an approved source? Or it's not like Lou dot whatever wrote this AES encryption. You probably don't want to test it or trust it rather. But if you get it from its official repository, then you're more likely to trust it. Yes.
Can you go back to your contact slide for 40 seconds? That's no more than 40.
I'll count that.
I was gonna say, can I get
40 seconds?
Get a volunteer.
Unless you interrupt me.
Wow.
Time with me?
I'm not, but
Not a 1 past 40.
seconds.
41 seconds, not 39 seconds.
Big picture.
You can also send out the slides afterwards too.
22 seconds.
you got a tough
I'm
crowd
done.
here. He's done.
Thank you.
All right. Well, thank you all.